Hello, I am Gustavo, a master's student here at Kansas State University, and today I am going to present to you a workshop about our Shine framework. Let's start? This is the content of what I'm going to present to you today. First, we'll move to a brief introduction, then we'll go to an explanation of front and back end, then I will show you what can be done on Shine. Later, I will teach you how to deploy your app. Then we'll move to a practice section where I will explain you and teach you how to do a basic Shiny app. Let's go. First, an introduction. Welcome to this workshop. Again, I will present you R, frameworks, web applications, dashboards, and Shiny. We will explore the definitions of each of those concepts and application of these technologies. What is R? R is a programming language widely used by scientists and data engineers to manage data and use it to build graphical information. R provides a comprehensive ecosystem for data analysis, visualization, and machine learning with the libraries of R. So, what are frameworks? Frameworks are pre-built structures that help developers to build applications efficiently. They provide a foundation of reusable components, libraries, and tools. So we have libraries. And libraries, imagine libraries like bricks. When we combine a lot of bricks or a lot of libraries, we have a framework. A framework is a bunch of libraries combined to be used easily to build whatever you want. In the context of web application or web development, frameworks streamline the creation of web applications, make it easier for you to create a web application. So, what are web applications anyway? Web applications are software programs accessed through web browsers. So you have Google Chrome, you have Mozilla Firefox, you have Internet Edge. When you access those browsers, you are accessing a web application. So they provide interactive functionality, allowing users to perform tasks and access information. And this you already know, since since now you are accessing it through a web application. Web applications, they are built using several different technologies and programming languages like HTML, CSS, JavaScript, and backend frameworks. So they are very complex. Dashboards. What are dashboards? Dashboards are visual interfaces that present data and insights in a concise and interactive manner. So I have a lot of data and a lot of different kinds of visualization of that data. Don't matter if it's science or company, if you build a dashboard, you have a representative way to show the data of you have in a way that everybody will understand and comprehend easily. They enable users to monitor, analyze, and explore data in real time. That's very important. Real time. So dashboards often include charts, graphs, tables, and other visual components that makes easier for you to analyze and see the data presented. So Shiny. Remember that I said before that to build an web application is hard? With Shiny, it makes it easier. Shiny is a R package that allows the creation of interactive web applications and dashboards. Remember that I said that to build a web application you need HTML, CSS, JavaScript, and backend. Now with Shiny, you just use R. R will make everything because it's a framework, has everything on Shiny. It simplifies the process of turning R code into interactive web interfaces. It enables users to build data-driven applications without extensive web development knowledge. Let's begin with front-end. Imagine that you are in a restaurant. In a restaurant, we have a lot of different processes going on. Imagine the front end as a menu. It is what you can see. The front end you are seeing now. You are seeing as videos, as titles, as description. It's basically what you are seeing. To build a front end involves HTML, CSS, JavaScript, and other frameworks like Bootstrap. HTML will provide the structure, CSS the style, and JavaScript will add the interactivity between the ones mentioned before. So front end, HTML. What is HTML? HTML stands for Hypertext Markup Language. It's the skeleton of an web application. So HTML is the standard markup language for creating web applications. So when you build an web application using HTML, you will have the structure of it. Next, the CSS. CSS stands for Cascading Style Sheets. CSS is the skin of your web application. With CSS, you can modify the color, the fonts, the layout, and many other stylistic aspects of your web page. Lastly, you have JavaScript, they are the muscles. I don't have many, but they are the muscles. JavaScript allows the interactivity, movement, a click option, and other kinds of dynamic content to your web application. So Bootstrap is another framework developed by Twitter that allows that has on it the three languages that I mentioned before: HTML, CSS, and JavaScript. It's very popular and used, and it simplifies the web development. It provides pre-designed templates, components, and responsive layouts to use while building your web application. And imagine, Shiny has already Bootstrap on it. Let's move now to backend. Backend, in our kitchen analogy, is the chef. So backend is where the things are happening, where the things are processed. Backend you cannot see, it's happening in the back. So all the process, all the data filtering, all the calculations, and everything related to math or management, it's happening in the backend. And to connect the front end and the back end, we have APIs, which stands for Application Programming Interfaces, which are basically our waiters. So API defines how different software components communicate with each other, so the front and the back. Like a waitress, the API will bring the information processed from the back end to the front end. APIs allow the exchange of data and functionality, facilitating the creation of dynamic web applications. So what can we do using Shiny? As I explained before, Shiny is a framework that combines everything on it. It combines front and a little bit of back end on it. So we have different ways to build a Shiny application. We have the base Shiny, and we have the Flex Dashboard. Flex Dashboard, as the name says, is more widely used to build dashboards. And base Shiny, it also can be used to make dashboards. But since you have more freedom with it, you can build other web applications with it easier. Lastly, before we move to our programming section, I will tell you the importance of deploy. First, what is deploy? Nothing matters if you build an app if you won't show it to the world, won't make it available to everybody. That's what deploys means. That you are deploying, you are putting in the web your application. To deploy an app, you have many resources. You can use mainly for Shiny, shinyapps.io. You can use AWS, Azure, and many other web servers. AWS, it stands for Amazon Web Services, and Azure, Microsoft Azure, are cloud computers platforms that offer deployment options for Shiny applications. They're a little bit hard to use, but you can use it anyway. Shiny Apps is a hosting platform mainly used and uniquely used for Shiny applications. In this video, I won't show you how to deploy an app, but in this link, you'll go to a website which teaches how to deploy an app step by step. So now, let's practice. So now, we are on our studio. This template, I will give it to you so you can modify. I'll teach you how to modify it properly in the next minutes. This part between the minus, it's very important because inside here we put essential information to our app. First, the title. I run the document so you can see how it looks like now, and by our changes you can see the differences. This is how our app is looking right now. It's strange, right? But later, as the video goes on, we'll modify it so it can look way better. First, let's modify the title. Instead of Shiny Framework Workshop, let's type Shiny is fun. Let's see what happened. See? Shiny is fun. This is our app title. If you want to modify your app title, you modify here in the title. Output. Remember that I said to you that Flex Dashboard is a library to build Shiny? So we are using the Flex Dashboard library and consequently the structure to build this app. It's important for you to have this Flex Dashboard here. The theme coordinates the style of the app. Now we have this default. Let's see what happened if I change it to Sandstone. I have all the themes here available for Flex Dashboard. If you want to change your app style, just change the theme here as I did. Let's run to see the difference now. See? The color now is green. Our font changed too. So we changed the style just typing a different theme here. Orientation. We can have columns and rows. Now our app looks like this. If I change here to rows instead of columns and run, it will change the layout. Look, now it's way better than it was before, right? And lastly, in this section, runtime Shiny. This is very important. If you don't have this runtime Shiny here, the app won't run as a Shiny app. We will run as an HTML page. In this application, I split the parts of the app in chunks. This first chunk, that is called one.load libraries and functions, I use it to load libraries. So in this first chunk, you load your libraries. You include all the libraries you are going to use. Like Shiny, this one, you have to insert Shiny themes, Shiny widgets, and the other libraries that you are going to use. It's important to remember to install the libraries before running the app. In the second chunk, I loaded the files that I'm going to use. I'm using this irisdataframe.csv. That's why I'm using the function readCSV. If you're loading a different file, like an Excel file, you can't use this readCSV function. You have to use another function to load your dataset in your app. Let me show you how the irisDataFrame looks like. So the ears data frame look like this. We have a data frame of sepal length, sepal width, petal length, and petal width of different species of flowers. So we have the measures, then we have the species, we have three different species, setosa, versicolor, and virginica, and its respective measurements. During this tutorial, I will come back to this file as I change our outputs. We can have different pages in an app. To separate those pages, we use this equal sign here. To set the page name, we put the name you want in the top of these equal signs. In our application, we have two pages, the main page and the about. So everything between equal signs, it's what will be inside one page. If we want to change the name of the page, we just change it here. Instead of main page, let's think of shiny first page. Let's run our app. See? Now we have the shiny first page here. We changed the name of our page. Our inputs. The inputs is where the user select what he wants to see in the outputs, in our graphs, cards, and tables. This is the inputs. For inputs, it's important for us to put these brackets and include inside these brackets dot sidebar. By including this, we will have a sidebar like this that won't change if I change the orientation of our app. Here you regulate the size of your sidebar. If you reduce this value, it will become smaller. If you increase this number, it will begin bigger. The sidebar, as the pages, has to be separated between these minus signs. We have this minus here and we have it here. So everything between those will be in our sidebar. We can insert text in our sidebar. Here I inserted inputs for the histogram. How I made this? By inserting this function, tags, $h, and I control the size of my text by changing this number here. Here we can have size options from bigger to smaller. H1 is the biggest and H5 is the smallest. So let's set a slider as an input filter. First, we have to remember, each input ID must be unique. If we have two input IDs with the same name, it will crash our app. So very important. So let's start. Let's make our slider input. With this function, slider input, you will create your slider. Inside the slider input, we have different arguments. The two first are the most important one. You will see these two arguments in all our inputs, which are the input ID, in this case I'll call it slider, and the label. Label is the text that we're going to show for your users to know what this input is related to. In this case, is the number of bins for the histogram. I'll show in the app. So now, here is the number of bins for our histogram. Let me change it. If I put 8 here, we'll have 8 bins here. How do I set it? Right here, min is the minimum of the slider and max is the maximum of the slider. And this value is the default value of your slider. The default values are the values which the inputs will show when you first run the app. Let's set the select input. We have the select input function. Inside it we have our input ID and our label. Inside of the select we have the choices for our drop-down menu. Here, if I click here in the select the species, we have versicolor and virginica. The first letter is in uppercase. Here, our choices. We have to put it as a list, as a vector. The first one is what is going to be shown in the app, and the other one it's what the value of the select input will have. Remember here in our data frame that we have setosa, versicolor, and virginica, all in lowercase. So this will be the value of our select input for later filtering and data management. Selected is the default value that will be selected in our input. If we change here to multiple, true or false, means that our app, our input, can have multiple values. If it's false, if I set here to false and run the document again, now as I set multiple to false, I can only select one species here. Let's set the radio inputs. Again, I put a text here to inform the user what are these inputs related to. Radio buttons, again, input ID and label. Choices, just like the select input, we have to put what the user are seeing first and then the related value. Here we have the sepal length, sepal width, petal length, and petal width. Here we have to put as in the data frame. Are seeing the dot here between sepal length, sepal width has to be just like our document here, where I have sepal.length, sepal.width, and so on. In our app, if I change here, we'll change everything because we are filtering, we are selecting the respective column of our data frame. You'll have to save and run the document every time you make a change, otherwise these changes won't appear in the app. Here I put another text to inform the user that this input is only for the box plot. Here we have a checkbox group input. We have again the input ID and the label, choices that again are the species as in the select input, and we have selected, I made a list to select everything. So here in our checkbox we have the three selected. If I deselect one, like versicolor, our box plot will change. Now let's move to the outputs. Here I have set this minus signs to separate the inputs from the outputs. This will be reflected in our app, where I separated the inputs here and the outputs in the rest of the page. I will make a little change here. I will uncomment this section and run again. Let's see the difference. Oh, now it's very different. Now we have our outputs split by tab sets. I made this by inserting tab set between brackets here. In the same way I did in the inputs that I inserted sidebar here, I inserted tab set here. This will change the layout of my outputs. In this bracket, I inserted my data manipulation processes. Here, I'm going to create a data set, a new data set for a histogram. How do I made it? I first created a reactive function. Basically, the reactive function allows the app to be interactive. It's very important to insert this reactive function when you are manipulating and creating new data sets, because otherwise, if the user changes the input, the new dataset won't be created. So we have to insert this reactive function and this parenthesis bracket, parenthesis here to close your data manipulation process. So here I took the dataset and filtered the species. Remember the column species here? The column species. I filtered the species that are selected in the input select. It's very important to put here this input $select. This way you make sure that the values that are going to be selected to be filtered are the input, which has the input ID as select. Here I created the histogram dataset, and now I will create the box plot dataset. Again, reactive function. Inside here I will get my dataset, my original dataset that I inserted before, and filter the species that are in the input $checkbox. This checkbox is the name of the input for our checkbox. Here we can see the inputs for our checkbox are Virginica, Versicolor, and Setosa. So here, let's just to make an example. In this box plot dataset, this new dataset, we'll filter our older dataset by selecting the species that are selected in this input checkbox. So in this chunk, we created new datasets. It's important to create new datasets for you to not change your original dataset, and if you change your original dataset, the things won't be reactive again. Here is a good moment to remember that the input ID names must be unique. If you have two or more with the same names, the app will crash. So now that we already said how our new datasets will be created, let's create the outputs. First, outside the chunks, when you put hashtags, it means that you are creating different hierarchies. Here we have 3 hashtags and a plot. Here we have a tab set named plot. Here we have 4 hashtags and a histogram. And here we have 4 hashtags and a box plot. Here we have a histogram and here a box plot. This means that inside the one that has a higher hierarchy, we are putting 2 that has the same hierarchy. Inside this chunk, we are going to create our histogram. Inside of it, we will create and render in the screen our histogram. First, we create this variable that is output, $, and the name that you want to have your histogram. To get values from inputs, remember to use input and $. And to create outputs, remember to use output and $. Here, we are using the render plotly function. The same way as the reactive function, we have to put parentheses and a bracket and close our operation here in a bracket and a parenthesis. Inside here, we are creating a ggplot that we'll call histogram that we'll use as data the histogram dataset that we created here, and after the name, it's important to have this parenthesis. This parenthesis means that this dataset is created by a reactive function. If we don't put this parenthesis here, this function will not work. And later we create our histogram normally. Here in the mapping, we are using the X, where we are accessing the histogram dataset. Remember to put the parentheses. And inside of it, we are accessing the column that the users input in the radio input. So let's go again in the app. So here, in my radio input, here, if I select the pedal width, here we'll have a histogram of the pedal width. So here, in this jump histogram, in the bins, I am inserting what the user input in the slider input. So here, if we change the number of bins, we change the number of bins in our histogram. Here, in the labs, I'll as the label in the x-axis, I am putting what the user selected in the input radio as a string to make the name of the x-axis. Here you can see that pedal width as pedal width, sepal width here, sepal width. In this ggplotly function, you have to insert the histogram, that is the name of your ggplot, and here you control the height of your plot. Here, if I change it to 160 and save the file, you have a smaller histogram. You can play to adjust the height of your histogram. Lastly, to plot your histogram, you have to put this function plotly output as you're outputting your plotly function, and you have to input your output ID as the name you inserted here, ggplot histogram. You put it here between quotation marks, ggplot histogram. Let's move to the box plot now. To create the box plot, as I created the histogram, we have to create this output, since you are outputting this box plot, $, and the name that you want this box plot to have. In this case, ggplot box. Again, render plotly between parentheses and brackets, and inside you are creating a ggplot named boxplot. In this ggplot, the data, again, important to have the data set that you created or modified, you have to have parentheses before it. The mapping. In our x-axis, we'll have the species, which is the column of our data set, species. In the y-axis, we have our boxplot data set, that is the data set we created, and again, parentheses. And we are selecting the columns that the user input in the radio input. And the color is selected by the species. So here, we have a radio. If we click in the sepal length, we are going to select in our original data set the column sepal length to be shown in our box plot. And here we can set our title, subtitle, and y-axis name. In this case, I am setting just like in the histogram, setting what the user input in the radio as a string. Again, the ggplotly function that we insert the name of the ggplot variable that we created, and then we control the height. If I put set here as 250 and run the document, we will have a better appearance than before. To plot this box plot in the screen, use again our plotly output function, which has the output ID as ggplot box, which is the same that we set here as an output. Now, in these hashtags, in the same case as plot, here we are creating a new tab called card, which we will display the cards which contains information of our data frame, which are the number of observations, the maximum values, and the minimum values. Let's create it. In the same way that we have here in the box plot 4 hashtags, meaning that inside the plot we have a box plot, here is the same. Inside this card we will have observations, maximum values, and minimum values. The number of hashtags outside the chunk is the hierarchy of your output. I created each card inside a chunk to be better organized. As in the box plot and the histogram, we have to output what we are creating. In this case, we are outputting a card. This card will be created inside this render UI function, meaning this is reactive, again, parentheses and brackets, and to close brackets and parentheses. We are creating a static card using the static card function. Inside this static card function, we have as variables this ID, that is the name of our static card. We have the value, which will be the number which will appear in our card. In this case, is the number of observations that are being plotted in the histogram. We have a subtitle, in this case, number of observations, like here, number of observations. We have an icon. To access this icon, you have to insert this function icon, and between quotation marks you insert the name you want. To know which icon you can use, I am providing to you in the folder a document which has the name that we are put here between quotation marks and the respective image. And here we set the background and the color of your font. For the other cards, will be much like the same. To output this card, you have to type this function UI output, and inside of it, between quotation marks, you have to insert the name of the card that you set it here in the output. In this case, card. To create reactive output and values, remember to insert parentheses and brackets in the beginning and in the end of your creation process. For the other cards, will be much like the same. The only differences are in the names, here card max, in the ID card max, in the UI ID card max, the same for the min, here min, card min, and UI card min. The colors of the background, here is green, here is red, the icons, arrow up, arrow down, the subtitle, maximum value, minimum value, and the value itself. In this case, I am selecting the maximum of the histogram that we created, and here the minimum value of the histogram. Lastly, in our outputs, we have a table. It has 3 hashtags to mean that is in a different tab. here we have our table. This table are showing our pure dataset, the dataset that we inserted in the app. Again, to output the table, you have to insert this output $, and the name that you want your table to have. Here, I'm using render data table, again, parentheses and brackets to show that this is a reactive function. Inside of it, we have a data table function that will create a data table, which will take the data of our data set. I am not using parentheses here because this data set was not created in a reactive function. This data was already inserted in the app, and here in the options we have a list of different options to style your table in the way you want. To output this table, we have to insert the function dt output, and between parentheses you have to insert the name of your output in quotation marks. Lastly, we have our about page, that here I set the name of the other page, and here the equal sign, meaning that we are creating another page. This shows that we can create plain text inside our app. See here that I didn't use any chunk. In this case, these hashtags are meaning that this text will be bigger than the rest of the text. Look here, welcome to the Shiny Workshop. And here my text, welcome to Shiny Workshop. See that it's bigger than the rest of the text because of these hashtags. And here we have bullet points. To make these bullet points, you just have to type in the beginning of the line a asterisk in front of our line. So this ends our practice session. I hope you enjoyed and learned a lot from it. Thank you so much for watching this video. If you have any doubt, please don't hesitate to email me. Thank you and see you in the next one.